Hello, I'm Vinitha. I'm a third year PhD student at the National Brain Research Center in India. This is also my third year with Neuromatch. The first 2 years, I was a student in both computational neuroscience and deep learning courses. Today, we'll be looking at polynomial regression. So far, we have looked at how to predict outputs from inputs by fitting a linear regression model. So, in a linear regression model, the relationship between your inputs and outputs is fairly linear. But in a lot of relationships that we see in biology, especially in neuroscience and many other phenomena in the world, what we see is a non-linear relationship. And so what happens is in linear regression, it only captures a linear relationship, right? But in a polynomial regression model, we can capture the essence of the non-linearity in any relationship. If you want to take a look at what a non-linear data would look like, you can see a relationship between x and y over here. These data points, they are non-linear in nature when the relationship between them is taken into account. So just to check out what the equations look like. In a linear regression model, it predicts the outputs as a weighted sum of the inputs, and this is linear, and the order of this equation is usually 1. So the order is the highest power to which the variable is raised to. But in polynomial regression, we model the outputs as a polynomial equation based on the inputs, and as each term increases, the order of the term also increases. So we can now change how complex a polynomial is fit by changing the order of the polynomial. So if you want to add one more term, that term would have a higher order in it. So just like this. So you see how the order of this polynomial can be changed if you add one more term over here, and the order of this polynomial becomes 4. Um, let's see how to design a matrix for a polynomial regression. So we have the basic idea of polynomial regression and some noisy data. So the key difference between fitting a linear regression model and a polynomial regression model is in designing the is in how we structure the input variables. So for so we do have we need to we need to structure a design matrix first. So this matrix x that we use for our inputs is known as the design matrix, and we want to create a design matrix so that we can use these x squared, x cubed, these weights in it, right? And thus we want to build a design matrix x for, let's say, an order k. So let's say k is the number, is the highest power in this one particular polynomial regression. So what we need is we need an array of just ones, and then we'll need whatever power, order of this polynomial is, that many vectors. Let's say x square, x cube, and so on until x raised to k. So let's see, and yeah, if you have more than one feature, that is also arranged in that design matrix. So that's how you think of design matrix. You will have the ones, an array of just ones. Then you will have, if there are, um, let's say two features. So you have xm, which is one vector of one feature per data point, and xn is the other one. So what happens is, in such a design matrix, the design matrix would look like that. So you will, since there are only two, you'll have xm raised to 1, then xn raised to 1, then xm raised to 2, then xn raised to 2, and so on until m raised to k and xn raised to k. That adds one more level of complexity to it. Let's look at coding exercise 2.1, and it will get a little bit better, easier to understand. So the structure design matrix, over here, we need to create a function called make design matrix that structures the design matrix given the input data and the order of the polynomial. So you have the input and the order of the polynomial, and you are going to print a part of this design matrix. And for our sake, it's order 5. Okay. So let's take a look at how it's done. You will have to uncomment. Okay, you have to comment over here. Create the design matrix. You have arguments here, x and order. Okay. So all of these are already defined. Okay, so here you have the array for ones. What you're going to do is you're going to stack them. So you're going to use the Python um, function for stacking, np.hstack, and its usage requires you to give the arrays that you want to stack on top of each other. So you have your design matrix, then you want to raise the power of x. to your degree. So yes, this should work. So when you print it, what you get is the first two columns of the design matrix, the X design matrix, and we'll further work on this. Thank you. That's it.